Hi, year 13. I want to just walk you through a little derivation, and you will see why by the end of the video clip, hopefully. So at this point, you will have seen my slide that tells you that you must remember that by definition, 1U, the atomic mass unit, is a mass, and it's equivalent to 1/12 of the mass of a carbon-12 atom. That is a definition that we have. Okay, so I want you to imagine we've got our carbon atom. We know then that a carbon-12 atom has 12 nucleons, and therefore the mass of the carbon atom in terms of atomic mass unit must be 12 of these, because by definition 1U is a 12th of the mass, so the whole mass must be 12 lots of this. Okay, so therefore one carbon atom has a mass of 12U. So hopefully we should be happy with this just from our definitions. Okay, now let's expand out a little bit. We know also that the Avogadro number, which is 6.02 times 10 to the 23, is the number of particles that we have in a mole of a substance. Now, remember that a mole is just an amount of volume with a specific number of particles. I know a lot of you are chemists, and it might be a little more complicated in chemistry, but what we are going to do at physics IB level is keep it super simplified and say that our total number of nucleons is our molar mass. Okay, so what that means is we know that whatever the total nucleon number is, we have that value in grams, and that will be the mass of 1 mole. Okay, so if we have carbon-12, then 1 mole will be 12 grams. Okay, please, big reminder that moles are working in grams. It's the only thing in physics where you need to be working in grams and not kilograms. I know that is confusing. Everything else you need to be making sure that you use standard mass of kilograms in your equations, but when you are working with moles, you must work with grams. Okay, I'm just going to illustrate 2 more examples of how we might find the mass of 1 mole of a substance by giving you another IB question. So this is a paper 1 question. It says a container holds 20 grams of argon 40 and 40 grams of neon 20. Our nucleon number, so the total number of protons and neutrons, tells me my molar mass. Okay, so what that means is 1 mole of argon must be 40 grams. 1 mole of neon must be 20 grams. Okay, so if I have 20 grams of argon 40, I must have half a mole. If I have 40 grams of neon 20, I must have 2 moles of neon. So whenever you see a question at IB, just look for the value listed next to the name of the element, and that is your molar mass. Okay, so back to carbon, which was our example. Because we have carbon-12, our molar mass of carbon must be 12 grams. So that means 1 mole of carbon is 12 grams. Right, I think I've gone through that enough. I know that I must have NA's worth of carbon atoms in 1 mole. So therefore, in 12 grams of carbon, I have Avogadro's number's worth of carbon atoms. Okay. I know this is me going over things quite significantly, but it can be really confusing for people. Okay. So, we know then that the mass of 1 atom of carbon must be 12 grams divided by the number of particles or atoms of carbon in that 12 grams. Now we know that in 12 grams we have this many atoms of carbon. So if we take that 12 grams and we divide it by the number of atoms that we have, we must have the mass of 1 of those atoms. Okay, so 1 atom of carbon is now 12 grams divided by Na. We also said earlier that the mass of one carbon atom is 12U. Okay, that's also in grams, remember. These two are equivalent. Therefore, I take my two things that are equivalent. 12U, the mass of one carbon atom, must also be equal to 12 over Na. I say that 12U is equivalent to 12 over Na. I can then do some rearranging. Okay, I'm going to pull Na up and I'm going to pull this 12 down. So I've got U multiplied by Na must equal 12 over 12, which we know is 1. Okay, the product of the atomic mass unit and Avogadro's number is 1. Now you may well be asking me, why on earth are you asking me to learn this? Well, let me show you a really typical multiple choice question that gets asked in your paper 1. What is the relation between the value of the unified atomic mass unit, U, and the value of Avogadro's constant, Na? Okay, well, I've just proven to you that if you multiply those two things together, you get 1. And that then tells me that I'm going to choose answer B. The product of these two things is 1. And I have seen this come up multiple times. Okay, so that's why I've just gone through this with you, so that you can see where that all came from. Now it's up to you whether you just want to remember that if you multiply these two things together you get 1, or if you want to go through this video again and just make sure that you're happy with each statement and you are able to derive it yourself. Okay, so basically we're looking at the mass of one atom of carbon from two perspectives, in terms of U, in terms of Na, and then we're basically just doing some rearranging until we can multiply U and Na together and we see that we get 1.